previous video, we're talking about the factor affecting the job site productivity. And in terms of the project work condition, the job size, basically the economy of scale, play a role in the productivity. And that's what I'm talking in the next with the problem one. So let's talking about the effects of job size on productivity. So basically, economy of scale, the bigger project, it tend to be with the same level of complexity, it tend to be more productive. And for this one, how to measure the effect of job size on productivities, it is measured by labor productivity index, labor productivity index. And to have that here, to demonstrate, I do the problem one in here. An engineering company has established that under a set of standard work conditions for structural design, a job requiring 2,000 labor hours is considered standard in determining the base labor productivity. All other factors are being the same. The productivity index, the labor productivity index, LPI, that you have in here, will be reduced to 95% for the job requiring only 1,000 labor hours. So as you can see the size going down, the labor productivity index LPI going down. So let's define that is the LPI in here. And then assuming that if a linear relation exists for the range of the job between 500 labor hours to 5,000 labor hours, they want us to determine the labor productivity index for the job that have 4,000 labor hours. So which is double of the labor hour for a standard work of the structural design. And we want to determine the LPI. So for this one, the easiest one is to just draw a graph for relationship between the job size and labor productivity index in this case. So we have the graph in there with this problem, which is simple. The first one is, as you can see, that is a job size, and in this case it measured by 1,000 labor hours, 1,000 labor hours. So that range from 500 to 1,000. So we can have this is 1,000, 2,000, 3,000, 4,000, 5,000, 1, 2, 3, 4, 5,000, and it linear relation from 500 to 5,000 labor hours. So that one here you have 0.5 for the job size, 0.5. And then the other one axis, which is the labor productivity index, that the LPI. And for this one, we consider standard for 2,000 labor hours, which is the index equal to 1 in that case. So in that case, 1, when it 1, the consider standard, that is 1 for LPI, then the size of the job is 1,000. And then we have the job with 1,000, the index only 95%. So going down, so we can have 0.5, and that is 0.9. 0.9, and of course that is 0.95, and we have 0.101, 105, and 101. So you have that one here. So from that we have, if it's 1,000 labor hours, it reduced the LPI at 95%. So we have another point, and that another point, and they assume a linear relation is sit in the range between 500 labor hours to 5,000. So you can draw a line between these 2 points, but it exists for the whole thing. So we can have that equal to going down further to 500. So it will be 0.9 now there, and linear relation go up there into 500. So it will be that point. And then the question asks, what is the LPI for the job size that require 4,000 labor hours of the, in this case, engineering hour for the structural design? And with that linear portion, so we can have that equal here from 4,000, go up there, and go down to the vertical axis, and that happened to be 1.1. Okay, so that what is 1.1. So what does that mean? As you can see from that equation, or from that graphic, if we do with very good scale, so that we can have the labor productivity index for 4,000 labor hours job, it equal to 1.1, and that should be the answer. So when we do the estimate for this project, whatever productivity labor hours, you may consider that, so that you can reduce the budget to make your bid more competitive. So why job site? Basically the economy of scale that you have.